Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. It is a Friday here. Things are kind of crazy. Crazy Friday. And we're right in the middle of font stuff. So I'm going to just go get right back into it. We were about to do stuff with language, although some people were mentioning that we don't handle spaces properly currently, and that's because of some stuff we did with kerning. So we should probably fix that first as a trivial fix. So we have some stuff we want to do with fonts. And so I think we should try to get some of that done today. It's a Friday, so we don't want to open up anything major, but we should be able to just do some analysis of our stuff, figure out exactly what we need to do, maybe put a little bit of it in there, and get ourselves in a good position so that we know what we need to do next week to wrap up the font stuff for good. And then we just have fonts, and everyone's happy, and we're fonting, and it's great, and everyone loves it. Okay. So like I said, just want to get started. So if you are following along at home and you pre-ordered the code on handmadehero.org, pre-ordered the game on handmadehero.org, you can download the source code and unpack day 173. Today is 174, so 173 source code is what I am starting with. And so if you want to follow along, that's what you'll unpack, and you'll be right where I am starting now. All right. So we pretty much had fonts working to my satisfaction, you know, to the level that I think we need them to be for this particular game, which is granted not too much in terms of complexity. But some folks were saying that spaces weren't working, and I can already know why that would be. So let's go ahead and just debug that one thing first so that we don't have to worry about it later while we go ahead and do our language stuff, right? So if we want to do our debug cycle count stuff, that's probably cycle counts. Yeah, so that's got spaces in it, right? And so there should be spaces there, and they're not. So that's an easy test case. Why aren't the spaces there? Let's figure that out, right? Well, the reason, I'm pretty sure I already actually know, but the reason for that is because spaces are going to do kerning just like everything else. And we changed the way we were doing our kerning, right? The way we're doing our kerning now is it happens inside this character operation set. And this character operation set never actually looks at space, because space isn't a glyph that we actually ever need to draw, right? It's empty. There's nothing there. So we skipped it. We didn't bother exporting it because why bother exporting something we don't think actually is going to be used? However, that means its kerning table will never actually get set. And so what we want to do is we want to make sure that we handle space properly so that it actually gets added. Now, there's a couple ways that we could do that. The easiest one is to actually store a glyph for font, right? I'm sorry, for space, right? We can just do this. We can just say, all right, there we go. We've got a space. Now it'll go through the standard path and presumably should actually work. Although I'd have to think about whether there's anything we did in the kerning code that would cause that not to work. Like, for example, because of the way we were trying to get alignment to the left edge and stuff like that. So since we're not exactly doing the exact same thing Windows is, I do think we're not 100% guaranteed to have this work. But that's at least the first pass thing to try. And yeah, so there we go. Not actually working, as perhaps I should have foretold. So anyway, excuse me. Yeah. Gonna say I don't even actually remember now that I think about it. I don't think I even actually remember where we landed on the kerning thing. Did we use the get char width 32? Yeah. And then when we do our kerning tables, that seems like that should have worked. You know what? I take it all back. I take all of it back. Our kerning table should have had the kerning value added into it. So although we may need to do this to extract the original value, I think I revised. I think I didn't really know. I thought I knew, but I didn't know. I suspect the real reason is actually because we may... Yeah, that's the real reason right there, potentially. Do we actually handle everything else properly? No, we're fine. We don't look at spaces, but that's okay because we don't actually need to render those spaces, right? So this right here, the get horizontal advance for pair, should have done it. Yeah. All right. So I'm going to have to go debug this. This may be a little trickier than I thought it was going to be. I was hoping it would be simple. So yeah, what I imagined was happening I'll just say it, even though it apparently wasn't the truth. What I imagined was happening was that our kerning, right, for spaces, maybe there really wasn't any kerning for spaces for the most part. And so what was happening was, because we never actually ran the kerning code for the space character, because it never had its glyph stuff processed, right? I just assumed that that would probably be the reason why it wasn't getting advanced. This part right here is the part that actually computes, that does that additional kerning. And so it seemed to me, I felt like that would have been the reason why we didn't get any space kerning, Yet when I actually did this, which should make sure that it's called, right? If we rerun the asset packer, there's no spaces, right? So where'd the spaces go? So what I'll have to do to figure out why we're not getting those, since it's not what I thought it was, we're going to have to go take a look and see what the kerning for space actually ends up doing. My assumption is that the easiest way to do that is to switch to the asset packer. There we go. Switch to the asset packer and actually just set a breakpoint and stop when we're actually processing the space. So, we could do something like this where we set a condition on this breakpoint, which is that code point equals space, right? Or not. Well, is code point not done that way? Is it not capitalized or something? No, it is. Huh. All right. Well, I'm going to go a little bit further down that road then and say inside test asset builder CPP, I'll stop manually in that case. If code point equals space, int y equals 3. So now I can set a breakpoint there. Well, it turns out it probably is what I thought it was, which is to say that the space is not running, but, oh snap! It's because there's another reason it might not run. Space contains no characters, so its glyph will never get packed. Oops. Looks like this has to happen outside. Well, so I had the right cause, but I didn't actually implement the fix properly, as it turns out. So there we go. Oops, that's the asset builder. Wanted to run Handmade Hero. Yep, there we go. Although, wait, no, still not quite right. Where is our little baby guy? Where is the little dude that normally comes right here? Right? It's debug space cycle space, and there's nothing there. So is there some kind of really nasty big value that's wrong in there or something like that that we need to pay closer attention to? Let's see here. Char advance, kerning change. That's probably not okay. That's just uninitialized garbage there, right? So if we want, what we probably want to do is set this only if we actually, right? We won't change the kerning if there was no actual thing to change, right? But we will otherwise. So that way it's just going to be char advance and it'll be -0 and it won't update this. So that seems a little bit better. So you see what happened there. That was just like some cut and paste cruft. There we go. All right, so I think that's probably mostly all we would need to do for fixing spaces. It looks fine. I wonder, are they big enough though? I guess we should double check against the thing to make sure that we're actually parsing those okay. Debug cycle and WA ta. That looks about right. That looks pretty close. So looks like we're handling the spaces now pretty well. All right. Okay. So there we go. That's where we're at. You know what? I have one other thing I want to check. Because we're going to start doing language stuff here. I want that Tokyo. I was doing Tokyo there, right? I think was what I was doing. Maybe we should do something more appropriate to Handmade. To Handmade Hero. Like, you know, something like owl. Let's see. Search. Short-eared owl, long-eared owl, burrowing owl, Eurasian eagle owl, snowy owl, great horned owl. I think we're gonna go with this guy, a short-eared owl. Looks good to me, right? A short-eared owl of shame, of course. So let's go ahead and put that in there. And so what I'd like to do is I'd like to get it so that we know like what these code points are, right? Because I don't know what they are, and I'm not really sure if Windows provides a good way to do it. So I want to do two things. First of all, I want to verify that these are actually in Arial. So Arial actually has, does it actually have all these? I don't even know, right? I have no idea if it does or if it doesn't. So what I'm going to do is I'm going to pick some random stupid font that probably wouldn't and do it. Okay. So it looks like Arial does actually have those guys. At least it would appear. Because when I select some other font, those go to nothing. So I'm assuming that if we stick with Arial, we will actually be able to get some characters from the kanji alphabet. So let's find out what these code points are, because I don't know. Code point. Let's see here. Where's the, there was like a code point lookup tool. Code point lookup tool. Or tall, or just tall, it's fine. Doesn't matter. Don't worry about it. So if we cut and paste this in here, give me the lookup. Okay. So that's it, 5C0F. So I'm just going to manually enter these in at the moment. So let's see here, handmade.cpp, and I'm just going to make like a little note here for when we need them. 5C0F. Whatever this is. 8033. And 6728. Last one. 514E. Okay. So now we've got some semblance, and you know what? I'm gonna save this guy. Save as desktop. Kanji owl. .text. Oops, okay. Sorry, didn't mean to do that. Encoding. Let's do UTF-8. Why not? Desktop. Kanji owl. There we go. All right, so now we've got our kanji owl spec'd out. And there we go. Okay. So, what do we do now? Let's talk about this, because we got problems, as you can see. There are problems, right? This is our kanji owl. We've got problems. So as you can see from this right here, the span of these characters is pretty massive, right? And so if we were going to use any kind of direct lookup tables, it's going to be pretty ugly, right? They'd be just too huge. We're at least going to span between 5 and 8. So we're going to span at least 3 in the upper thing there, which is, you know, shift up by 12 bits. So that's just, it's too much, right? We don't want to store a 2D lookup table for kerning at that size, certainly. And so that's just not, it's not a good scene. Furthermore, even our 1D table would be pretty crazy, because our 1D table would have to go all the way up to 8033, right? Which is quite high. Here's me pasting it into Visual Studio. That's a 32,000 entry table. Now, the total number of Japanese symbols we'd probably need to represent the items in our game is probably going to be like 500 or something, right? So we'd be storing a 32,000 entry table to store 500 things, and that's kind of ridiculous, right? Because almost every entry in it would be 0. So we're going to need some way of condensing our stuff, right? We're going to need some way of condensing down. If there's only 500 symbols that get used, we're going to want to condense down to things that are only of the order 500 and not things that are of the order 32,000, right? So how do we do that, right? What are we actually going to do? What are we actually going to do to fix that? Well, let's start with the easier problem, which is just the 1D lookup, okay? So obviously, if we wanted to store this in a very straightforward fashion, and let me put the day number down here. If we wanted to store this in a very straightforward fashion, right, we would just do something like, okay, right now we just had a flat array and we assumed what the numbers were. So we had something like, you know, A, B, C, D, E, and so on. And we just assumed that like it was like 0, 1, 2, 3, 4, right? And that would work for any contiguous set of things. In fact, even if this is not 0, if we want to condense down the fact that we know we don't really need 0, you know, because we started at like 33 was our first character or something, storing an offset of 33 would totally condense that down, because we pretty much had a fully dense range of characters in the ANSI set. All of them were ones we probably would have used, so we could have just stored 33 over to tilde and be done, right? And that would be perfectly compact and all the information would be nice and it's fine and whatever. However, once we start having things that look like, oh, 12,000, you know, 3 or whatever, and then the next one is like, you know, 15,472, there's this giant gaps in between things. And this no longer, the assumed thing no longer works. So the easiest thing to do, if we didn't care about how long it would take us to look up, right, the easiest thing to do would be to just make the table enclose the numbers as well. So instead of implying the index, we would just store the index. So we'd essentially tag each thing with its actual code point, right, or whatever it was, and be done with it. Then, when we have a string like foobar, we know we can just go ahead and look up into the table. Whenever you see F, we go find the code point for F. You know, I don't know, whatever it is. It's 37 or something. I don't remember, 39. Who knows? I have no idea. We go find where 39 is in the table by searching through it, and then we pick the letter. Now, we could do a faster search than linear, potentially. We could do like a binary search, potentially, although sometimes binary searches are kind of slow because it's unpredictable cache-wise and all these other nonsense things. But in this case, I don't really think that would be the case. Point being, we could do a binary search or something to accelerate it so we don't have to visit every single item, but we would still have to do some kind of a search there, right? Now, probably that's the kind of thing we would have to do if this were a game that allowed you to like enter text, right? If this were a game that would allow you to like type text into it. Because if you can type text into it, then you can enter whatever you want. And we have to be able to convert whatever you enter, right, into something that we recognize. However, in the case where we actually, the strings are ours originally, right? We created the strings. Then one thing that, an option that exists for us that would not exist otherwise is we could actually pre-process the strings instead to map them into a pre-collapsed set of of tables rather, right? So if we have this and we say we're going to map that to 0 and that to 1 and something to 2, right? Then we go in and we see, oh, when someone uses code point, 12,003 in a string, we just go through the mapping table, map it to something, and then output the 0 instead, right, of the actual number. And so for this game, it would seem like that's probably the smartest thing to do, actually, right? That seems like a much easier way to go, because then we would never have to do anything expensive at runtime. It's always direct lookup, and the tables are always maximally tiny. So the cost is you can't generate new strings at runtime. However, even that is not necessarily true. We could also, right, ship some kind of a compressed table. So, oh wait, maybe this is just a smarter thing to do in general. Yeah, this is probably the smarter thing to do in general, huh? All right, so I might be a little bit stupid. Okay, that's true. Let's not harp on it. All right, why do you even bring that up? Why would you go ahead and bring that up? Are you just trying to hurt my feelings? Because this is not polite, right? I'm trying to stream this. I'm doing this for you at the end of the day. You shouldn't call me stupid, right? Like in the middle of that, It's impolite, really, is what I'm saying. So rather than do that, why would we bother doing that when instead what we could do is just have one 64K table, right? 64K entry table, so 64K2, so 128K table. We could just have one 128K table, or rather that goes up to whatever our maximum code point is. And then in there, we just store for the currently selected font where it actually maps. That would actually be pretty darn easy. Then you can just enter text all you want, right? And nobody cares. So that seems like it's probably a smarter way to go. So let's go that way. I think that pretty much just answers it right there. Yeah. Seems easy. Seems really trivial to me. If anyone has any objections, you can voice them in the chat, and I hereby overrule them. All right, so let's take a look. Let's take a look at what would happen there. So really not much has to change. Not much has to change, folks, if we want to do that. So if we go in here and we take a look at our file format, so really we only need one thing. Very, very simple thing, which is that in our table of bitmap IDs, we've got that, right here. In our table of bitmap IDs, what we actually need to store is something slightly more complicated than a bitmap ID. We need a code point plus a bitmap ID, right? So we just need something that's like, HHA font code point or something like that. And it just says, like, here's the code point, and then here's the bitmap ID. And then now, when we store this, we just say, oh, okay, this entry in the table, whatever entry it is, represents this code point in Unicode, right? So this is the Unicode code point. And then this is the bitmap. This is the bitmap ID for that. That's it. So then when we load the font in, if we want to use the font, we just unpack that table basically we decompress this into a table that's actually direct lookup, and that's the end of it. I really don't think there's anything else. There's nothing else to be done. Yeah. Can't think of anything else anyway. I felt like this was going to be harder than this. I wonder if I'm just forgetting something. I guess now the memory's so cheap, when you can have a 128K table, things get a lot easier on you, I suppose. Maybe that's the lesson learned. I don't know. Anyway, let's keep going. So if I go into the test asset builder, and now I'm going to go ahead and change that. So we've got the bitmap ID here. And I'm going to go ahead and change that over to being an HHA font code point, like so. Then, when I come through here, no, that's fine. Yeah. So when I come through here and write our bitmap IDs, I need to do a few things. First of all, the bitmap ID size is actually not going to be that anymore. It's going to be one of these guys. So HHA font code point. Yeah. And then I don't know that there's really a whole lot else we need to do other than set it. So when we do this, we just have add character asset. We'll have that actually return one of those instead, so we can still even use this exact format, in fact. Although now I think about it, this gets even simpler. So yeah, I guess we don't even really need to do that. Here's what we would do. We would do code point or local index, right? And then what we'd do is we'd set that one. Yeah. We would set that one each time through. So we'd do something like this. Let's see. We would do HHH font code point, and this would be the code point thing or whatever. It's code point. It's not the right name. What are we gonna call that? Font. I guess it's just the glyph. I don't know. We're going to call it a glyph. Okay. So if I come in here and I grab that out and I just say glyphs or something, who knows? So I grab out the glyph, the bitmap ID that goes with it. We get that. The code point that goes with it, I know already, right? It's this, like so. And I think that's just about it, right? And so the actual character range for this thing is kind of a little confusing because it includes the space, but that's okay, right? And so what we would have to do here is we'd have to say, we'd want to do essentially this operation for the space as well, which is kind of a little bit annoying. I guess we could just copy and paste it. Who cares, right? At some level, this is, like I said, this is kind of throwaway code in this asset processor. So yeah, we could just do it that way, right? We could even go a little bit further here and do that if we were feeling particularly enamored with ourselves, right? And you know what? We could do something else too. We could do something even more ridiculous. I say that it's throwaway code, and then I go and do these things. That's how you know that you're kind of a programmery sort of person, I guess. Yeah, what are you gonna do? Anyway, inside here we actually could just do that part of it. Now that I think about it, right? We could just do this in here. So we take the glyph for that font. We take the debug font itself and do, something like, okay, debug font glyphs, debug font, glyph count or something like that. And we increment that. We assert ahead of time that the glyph count is less than the max glyph count or something like this, And then this stuff gets written in automatically. And yeah. And then the bitmap ID just gets set. Like that, right? Then we don't care about this anymore. And we don't care about this anymore. And we don't care about any of this. We just say we want that. And we want these. Please give them to us. And we won't, you know, shoot the hostage. We'll be the bigger man and not shoot the hostage. Okay. So if we do something like that, which makes this much cleaner, right? It also means that I can go ahead and add, you know, we can sort of see, in fact, exactly what I'm going to add here in a second, right? You can imagine our kanji owl. Our kanji owl is going to be something that would do, you know, something like this. Begin asset type font glyph, right? Add character asset, and then we would literally just add the ones that we wanted, right? In fact, now I think about it, we could do that right inside here. In fact, I'm just going to do it, right? Who's going to stop me? No one's going to stop me. You can't really stop me. That's the thing, right? It'd be really difficult to stop me because at this point, probably even on the Twitch stream, the lag is such that by the time you hear this, I will already have actually typed it. So even if you could somehow stop me, you wouldn't have known in time to stop me. That's the thing, right? That's the whole situation. I'm gonna go ahead and say kanji owl, right? Because it is. Anyway, so there's our kanji owl. And now we can just add code points to our heart's content. Yeah? And so what we need to do now is we need to back out the use of the character, which is not really so interesting anymore, and start using the index of the character everywhere that we were doing our addressing. So we do have a bunch of work to do, but it is not hard work. It's just sort of mechanical, right? Because if you look in here, we'll also do a thing here, which is just like, right, max code point count, or max glyph count, max glyph count equals, I don't know. Nobody better make a font with more than 5,000 characters in it. Note, Casey, 5,000 characters should be more than enough for anybody. Right? And you know it's true. You know what? Let's make it 64K. Because that's close to 640K. I don't want to do 640K because that actually is more than enough for anybody. So I want to do something that's actually kind of slightly comically low. Right? 64K should be more than enough for anybody. Right? I mean, can you imagine a situation where you would need any more than that? I can't. Right? And so, yeah, is that going to be too much? Will that blow out anything? 640 by 1024 times 640 times 1024. That's too big. That's still too big. That's going to be like too big for the table. All right, so I'm gonna actually say it's just 5,000. 5,000, 2,000. 2,000? 3,000? I don't know how many we want. Calc. 3,000 times 3,000. 9 megabytes, totally fine. 5,000 times 5,000, right? 25 megabytes, not a problem. So I'll let it go up there. There we go. All right. So now that we've gotten that crucial thing out of the way, I'm going to go ahead and set some stuff up here, which is to say that I guess we got loaded font, which should be somewhere. There it is. So we've got loaded font. Why is it? Why are these in here instead of out here? Does anyone even know? I don't even know. Nobody knows. Nobody cares. Anyway, So if I have my loaded font here, what I'd like to do is now say, all right, there's not going to be a code point count per se. There's going to be a glyph count and a max glyph count. And you know what? Min code point and a max code point might be good as well, right? So we know like what range it actually maps to, something like that. All right, so I'd like to do that. We can set the max glyph count here, and we'll set it like that. Font min code point equals, you know, some extremely high value, int max, let's say, font max code point equals 0. And then we've got this glyph count 0. So that's good. And then in all here where we're doing like code point count and stuff like that, we're going to use the max glyph count instead. So now we just know however many glyphs we think. And you can see what I'm doing. I'm changing, right? We were previously counting code points, which are actually entries into the real Unicode table. We're now going with glyphs, which is our own numbering for the actual glyphs we're storing, which are totally sparse. They're spread out through the Unicode code point. They are not, right, contiguous at all. So that's why I need to introduce this concept of two different, you know, types of numbering, essentially. Okay. So now we have a slightly harder time because since I'm not setting how many glyphs there are ahead of time, it means that our stride is still based on the max glyph count, but it means we won't be able to write this table out in one shot anymore. We'll have to write it out in a very different way, but you'll see that when we get there. So yeah, I don't think we'll probably finish this by the end of today, by the way. But the good news is this, I think, just pretty much finishes everything for us. So once we do have a chance to finish it, maybe Monday or Tuesday, it'll just be like, ah, good, fonts are done. Guess what? Got a present for you. Knock, knock. Who's there? Fonts are done. Fonts are done who? There's no fonts are done who. The fonts are just done, right? Stop knocking on my door. I don't know why, although in that case I would have been the person knocking. Doesn't matter. It's not relevant. Point being, what we want to do now is we want to go ahead and start treating this mapping. We have to have our own mapping now. Because we've got sort of this whole kerning pair situation. We need to be able to map the actual Unicode code points into something we can actually use. I guess, you know, now that I think about it, that may mean that we want to actually still index these guys by the Unicode code points and just allocate a gigantic table for them only at asset packing time. I'm kind of like with that, you know what I mean? This sort of thing. Yeah, so here's how I'm thinking it. Let's hear me out here. So in the asset packer, we allocate one big old table out to the max code point. So whatever the maximum code point is, we don't care. It's 64K, let's say. So this table just stores where we actually put each one of these guys so that we always have a mapping table back to our own glyphs type, right? So basically, when we you know, create one of these fonts, we get something in here, which is, and this will just be some kind of a pound define, which is like max font code point. And so the maximum code point that we're allowing is you know, this one or something, right? Who knows? What's the highest Unicode code point? What is the highest Unicode code point? It's like, what's the largest number? What is the largest number? According to standard, the highest code point is OX10FFFF. That's from Stack Overflow, though. Can you really trust it? The character encoding scheme ASCII, blah, blah, blah. Unicode comprises parameters to 10 FFF hex. The Unicode code space is divided to 17 planes, the basic multilingual plane and 16 supplementary planes, each with 65,536 code points. Thus, the total size of the Unicode code space is 17 times blah. Okay. So 10 FFFF hex. How much do I care about that? Is that a bad size? Doesn't look it to me. OX10 FFFF. Nah, that's nothing. For the asset packer, because we don't care. The asset packer can allocate memory like a fiend, and no one cares at all, right? So, bam. There it is, folks. Maximum code point is going to be that, right? And so, yeah. So if we want to do that, then all we have to do is when we malloc this friendly little font here, our loaded font is going to need... I'm pulling these guys. I'm pulling them. I'm doing it. Don't try to stop me, because I won't let you. Honestly, that's just the truth. Test asset builder.h. Is there a reason this doesn't include windows.h up there? I'm gonna go ahead and do that. Like that. Yeah. There we go. All right. So it's not called that anymore. There we go. Code point count. Max glyph count. We are back to where we were. And so what I was going to say is the loaded font itself needs to store that mapping table. And that mapping table is just a thing that's saying, okay, it's our glyph index from code point. So it is just something where you can plug in the Unicode code point and get out the slot, you know, the index in this font where that code point exists, right? So, you know, it's going to be something where we just malloc some large number of that, right? We say, okay, you know, like so. We allocate however many the max font code point is. We know that that way we've got room for them all. And then we would presumably initialize them all to 0, which is to say that by default, none of them are in the font at all, right? They're all not there. So yeah, so that's that. Like so. So assuming, I can put that down here, I suppose. So assuming that we go ahead and make that table, I should also make a little thing that frees the font here. Just gets rid of all the tables and stuff. The glyphs. The horizontal advance. The glyph index from code point. And we should probably also just guard it like so. Not that anyone ever frees a font, but if they were to, might as well do it right. Seems like. I don't know. Anyway, so in here, we come through and we go ahead and we allocate the font. We allocate the table. We clear the table to 0. Gotta have a 0 in there. We allocate as many bitmap IDs for that table. This is going to actually be our glyphs table now, right? We allocate as many of those as we can maximally hold. We do the same thing for our horizontal advance. We then clear it out. And then this, you know, essentially this can still be exactly the same. The only difference is we can't do it now because we don't have a mapping, right? we don't have any way of actually mapping the kerning pair. So we need to kind of do that kerning after we've already done all of our mapping, right? Because these are supposed to be glyph indices, and they're actually Unicode indices, you know? And so we need to translate them through our mapping table, but there's no way for us to do that until we've actually extracted all the characters, right? So if we were to do that, how would we do it? Here is where we do our kerning after the fact. We get our kerning change here. We look up the code points. The way that we do this is we just straight up add this change to all the code points that involved us, right? And so that is something that we could actually just bake out at the end, right? It's something we could very easily bake out at the end, in fact. And so I think I will. The way we would do that is we would just store this kerning change into the actual record for this font glyph, right? We'd store that, and then all of this would happen separately. Char advance minus kerning change. We know what char advance is. We would know what kerning change was. In fact, we can just say that we would write kerning change directly into that table. I think that'll work. Since these are sums, my argument is that this right here actually is just other glyph index now, right? And it can just stripe through the table, essentially just doing it to everything. It can just basically preset the table for this character, the entire table, to just have that value sitting in it, right? And so all it needs to do is say, oh, okay, whatever the other glyph index was, and I know what my glyph index is, because now it's been assigned, right? This should just work. I think that's good. I think we're good. So if I do that, this is going to have to be by stride. So I feel like at this point, too, horizontal advance, you almost want a utility function for looking up into it because so many people are doing this nonsense. So we may go ahead and do that later. I'm not sure. It's in the back of my mind, though. So if we went ahead and did that, that would just work, I think. The glyph index would get assigned, presumably, in this sort of pass, right? So when we do load glyph index, we would pass it a code point and a glyph index, right? So we'd say we want this glyph index, it's rendering this code point, yeah? And presumably, actually, it could even look that up into the code point table. So it could actually do something where we said, oh, okay, the glyph index is just whatever the font code point table, glyph index from code point, it just grabs it out of the font. Yeah. So I think we could just do that. I don't even know why I'm compiling yet, but that's just pointless. Anyway, so I think we could just do that. I think that's fine, and we don't need to do anything special. So really all we have to do is move this thing out to the end, right? So essentially we want to do that like right before we write out the font so that we know that all the characters have been extracted, you know? So, you know, like this happens, right? Like here. And so in order to do that, I don't know that we really want to dump it in there. So when it actually does the load font, I might do something like introduce a thing here that's like, finalize font kerning or something like that. And just in finalize font kerning, we do this stuff. Now, we obviously are going to have to actually select the font in because we don't know that it's the active font. So we select the font in, we'd get the kerning stuff out of it, right? We'd go through, and then in here, we would now be able to actually do the thing we wanted, which is like first and second are going to be glyph index from code point, right? There we go. So now they're converted to glyph indices, and they can be used to index into that table, which is what we wanted, right? Where is my free? Where's my free go? My free is missing, and I feel like that's bad. There it is, it's right there. Okay. That is not where it's supposed to go, just in case anyone was wondering. Not where it's supposed to go. Okay. So that's fine. That's where finalize font kerning will happen. And so I'll just do it here, finalize font kerning, and that will take the font, like so. And then for the horizontal advance, this will be the glyph count. This will be the glyph count as well. This will also be the glyph count, but the code point size will be the HHA font glyph. We're then going to write them out. Like so. However, this will not work. It won't work because this table was bigger than the one that we're actually going to write out, right? And so really what we need to do here is do a series of writes that only write part of the thing. So this is a slice, right? It's one slice of it. I don't know if this makes sense, but we made a table that looks like this, and we're actually only outputting a subsection of it, right? We're only actually outputting some smaller bit, right? And so when we actually output this, we just want to output, a row, then advance to the next one and another row, and we're skipping a bunch here because the max glyph count is not equal to the actual glyph count. So there's just a bunch of unused space, and we're not going to write that out. So yeah. So we want to just do glyph index equals 0. Glyph index is less than font glyph count. Glyph index. And the slice size is not squared. It's just one of those, because now we're looping over each one. We want to write out the horizontal advance. We want to like stride it. We want to move, forward each time, right? So what we want to do is say, all right, we had a pointer, right? This is the horizontal advance pointer, which is that. And then each time we want to write that out, we're going to then add the total size of one of these things, right? Oops. So this is basically the same as like the bitmap copies we've been doing, only it's not a bitmap in this case that we're copying, but it's a 2D array that we're getting a chunk of, right? So we're starting at the top, we're writing out a partial row, and then we're advancing by the full row size. Oops, except that didn't convert to what I wanted. Horizontal advance, right? Something like that. Yeah? That way that table then condenses down to the correct size that the table should actually be, which is better than having it not be the size that it actually needs to be. I Can't really argue with that. So anyway, min code point, max code point, we set those up, max glyph count. The max glyph count is just going to be what we sort of said here. In fact, I guess I don't really need that to be redundant. I can just put it here and have it get set directly like that. The glyph count's going to be 0, and now these routines will all sort of do, I think, exactly what we wanted them to do. There they are, glyph index from code point, glyph index from code point size. That's all good. Okay. So, moving along, this stuff, actually, it's just max code point, max font code point. And really, it's not max font code point. It's like count. So we want that. Or you know what I could do? 1 past. There we go. That way, if you allocate a table, you have enough, right? Otherwise, you're one off. Anyway, so yeah, freeing things. Everyone loves it when you free things, and so on. All right. No, this was going to be good. You know, what are you going to do? All right, so let's see here. Other glyph index not equal to 0. Other glyph index. Boy, ran out of time. Well, I told you I was going to run out of time. I said we wouldn't finish this till Tuesday probably. So I don't know why I'm screaming, but you know, it's that you want to finish coding. You know, you want to finish. You know what you're doing. You know what you're doing, don't you? You do. And when you know what you're doing, you want to finish, right? You're in the groove, right? It's like it's totally mechanical and you can just go. And like there's no reason to stop. Why would you stop? You wouldn't stop except for the little thing at the bottom tells you you have to. And so you do. So yeah, I mean, I guess I got to wind it down. Don't want to, have to. So there's glyph index from code point is just going to be saying that we're entering the glyph into the table, like so. That's where it's going to be stored. So then we pull out that one, and then we, into the table here, issue the code point and say that maps to this glyph index, right? Very, very simple. So yeah, there we go. And code point count is not a member of loaded. That's true. It is not. But yeah, that's actually going to be glyph count eventually. So I might actually go ahead and change that already. It's glyph count. It's not code point count, right? And horizontal advance is actually that. Yeah? Okay. So there we go. And let's see. Font code point count. That's going to be glyph count. That's going to be glyph count. And there we go. Glyph index code point. And let's see. Handmade asset. Code point count is going to be glyph count. And we are happy about that. Okay. All that code needs to be changed, but at least we're compiling, and so now I can call it Q&A. But yeah, we still have, we've got another good hour left. So Monday, we will have to finish all of that up. But that's fine. Let's go ahead and go to the Q&A. If anyone has any questions about what we did, get them in quick. We're only going to have about 10 minutes of Q&A today because I got to go at like 6:15. So please put Q colon in front of the question so that I can see it. BK Boggy, I noticed that you rarely comment your code. Your comments mostly consist of to do. What are your thoughts on commenting your code, considering a lot of it is pretty complicated, unless, of course, you don't see it as such? Or do you think that since you write good code, it doesn't require comments to be readable? None of those things. Well, okay, I wouldn't necessarily say that the code is complicated. The This is not particularly complicated code, but the reason that I don't put comments in it is not because I don't think that they might help. The reason is because, and I can actually tell you that I don't know a single other programmer who doesn't echo this, who does, who does significant programming for a living at the kind of speed that I do. The comments get out of date almost immediately and end up being more harmful than if you didn't have them. Because someone will come and read something that says, this does blah, and of course it doesn't do blah anymore, and now it's worse than if they didn't have the comment. So the problem, essentially, is that comments don't go through the compiler. There's nothing checking them. And so if you wanted your comments to always be in date, you would need to put in a process whereby you manually check them or have them code reviewed or something, and that just slows you down way too much. It slows you down way more than having that comment accurate could ever have saved you. And so it's a bad trade-off to comment your code, in my opinion. I do sometimes comment code, and that time is when I have fully finished something, and I'm like, I am not going to touch this for like 6 months. I will then go in and write extensive comments into the header that's like, here's how this works, here's what you need to be aware of, here's what you're going to forget, right? And that, I think, is very valuable. But commenting code that is in flux is completely useless, in my opinion. It only ever results in a net speed loss, regardless of how you do it. Meaning, if you don't have a review process in place, it's a speed loss because you're going to have a ton of comments that aren't right, and that's a speed loss. If you do have a review process, the review process took longer than it needed to, and that was a speed loss. Much more than the comment could have possibly saved someone who was reading the code. So I don't see any point in commenting code in flux, but I do see a point in commenting code that you are intentionally putting aside for a long time, because that can be kind of useful. Why was your first calculation of the glyph table index size too big, 64K, and reduced to 2K, and still later went full on 64K again? What changed the size? I don't think it is 64K. It was 5,000, right? That. Yeah. The reason for that was like a table that's 5,000 by 5,000 is 25 megs, which isn't too bad. But a 65536 by 65536 table is actually 4 gigabytes, which seemed a bit too large. I just want food. Would it be a good practice to comment after writing all your code for others? If, like I said, if you know that the code is like done and you're not going to touch it, right? Except for like minor bug fixing things, then that's an okay time to do it. If you're still working on the code, just don't comment that. Just don't. Believe me, it's not worth it. It's going to do more harm than good. And I would also say that when you go to comment code, if you're going to put it away for a while, don't go comment like this is not useful. Right? You see a lot of comments like this, and it's like, that doesn't tell me anything I didn't know by reading this, right? So typically the comments like this doesn't need to be commented because I can read this and I know what it's doing. What needs to be commented is anything where I wouldn't know something about it from reading it. Like something like, now maybe I would guess that because of this, but that's an interesting comment for me, right? Like, oh, okay, this is something that runs multi-threaded. Maybe that helps me, right? Maybe you could put that in the name though, and then it would be a little bit better. Another example would be, don't comment like these functions because I can see what they do. Instead, I want a comment up here at the top that just tells me how does the whole system work? Because that's the thing that I have a hard time knowing, right? I can look at any individual, like comments that say how this function works, it doesn't matter. Like if I'm a good programmer, I know how the function works, I can read it. What I don't know is why this function is here, like what is the point of this function? And how does it fit into everything else? So like a nice comment at the top, a nice big comment at the top that's like, the Handmade asset system is made for reading files off the drive that are packed by an asset packer that follow the file format in HHA assets, whatever. It's built upon a series of tables that are flat loaded. Asset types are remapped at load time. Like, that's a good comment, right? And then I'm like, oh, okay, I see what it all does. I can then start, when I read this function, I know how the function works, I can say, oh, okay, whatever, right? Or like this generation thing would be perfect, right? Don't tell me, don't comment this. I don't need to see, I know exactly what this is doing. What I don't know is, what is a generation? Like, what does that even mean and why is it here? So a comment at the top that's like, generations are things that are used to make sure that assets don't get referenced after the time that they're evicted, and so it's maintained by the render group. Like that, again, good comment, useful comment. So I don't need to see any comments here. I need the gestalt. I need like the bigger picture. That's where to spend the time commenting, right? If you're going to spend time commenting, spend it there. Cuber Caleb, since the questions are slow today, when do you think you'll write a proper RNG? Probably when we go to do the world generation, I would guess. That's the only time we really care at all. Pseudonym 73, or a real hash function. No, we're never writing a real hash function, right? As I said, every game that's ever shipped has to have this comment in it, which I assume is why you brought it up. That has to be in every game. If we ship Handmade Hero and that is not in there, then I don't know what to say. We have not shipped a real game at that point, in my opinion. A real game has the comment, better hash function. So, you know, what we could do is there's a couple of these and they say better hash function. What we could do is like rewrite like one or two of them to actually be better hash functions. But as long as we leave one, then I guess I'm okay with it. As long as one of them at least says better hash function. James Widman, my comment writing rule for a while has been code should clearly tell you what is being done. Comments, if you need them, should only tell you why. Yeah, I mean, I don't know that I necessarily subscribe to that because it's not for me about a what or a why. It's more about level of detail. I want the high picture. I want the big picture comment. And that big picture might be a what comment, but I just need that big picture. It's the fine resolution that I don't need because that's what the code does, right? If the code is that hard to read, maybe you should think about rewriting it to be a little bit easier to read, you know, like name things a little bit better or something. You know, but yeah. How long have you been coding? Years? 31 years. Abner Coimbray, when will you implement the chocolate wine fountain? Probably, that's more of a Yangshan thing. But we will definitely, Yangshan will definitely be doing the chocolate wine fountain. The question is just, will that be in the, and the answer is you're probably going to be waiting a while, right? Because that's going to be in the Abner Coimbray chocolate wine expansion pack. So that's got to wait till the end of everything. I mean, I apologize, but I mean, if the whole expansion pack is named after it, it can't, the chocolate wine fountain had better be in that pack, right? I mean, that's kind of a no-brainer, or people are going to be like, WTF. So. All right, guys. No more questions? No more questions. I'm going to call it. There we go. All right, everyone. Thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you wanted to follow along at home with the series, you can always pre-order the game on handmadehero.org, and it comes with the source code so that you can play around with it at home and learn from it and do all kinds of crazy experiments. We also have a Patreon page. If you want to support the video series, you can subscribe to that. We also have a forum site you can go to ask questions, get community ports to Mac and Linux, look at a community annotated episode guide that can help you catch up on past episodes. All kinds of good stuff up there. Really great stuff from the community. It's really worth checking out if you haven't already. And finally, there's a video. Oh, no, that's not true. Finally, there's a tweet bot you can check the schedule on. It tweets the schedule on weekends and tweets every day when the stream's going to be that day. So it's really easy to like catch the series live if that's what you want to do. So that's about it. I think we've more or less finished the font stuff. Like, I think this design will actually be fine. So it's just a question of spending the final hour or two of programming next week on making sure all the glyph stuff lines up. And then I think we're pretty much good to go. We'll be able to support multiple languages that way. We'll just have to come up with some tagging scheme so that we can pick fonts more intelligently, because we might need something that's like a tag. You know, in our asset system, we don't have a tag right now. We could define a new tag for like language. So that, you know, if you're trying to do, you know, if you're trying to run the game in Korean, it would pick a font that has Korean glyphs in it by setting a tag or something, just to make it so that, you know, because not all fonts are going to have all glyphs, would be my assumption. So there's some stuff we could do there. So you know, maybe there'd be an extra hour next week or something about just making that system a little more robust too. Or not really making the system more robust, but coming up with whatever conventions we want there that would work well. So hopefully you'll join me for that. Again, check that tweet bot if you wanted the schedule for next week. I posted on the weekend. Until then, have a great weekend, have fun coding, and I will see you guys on the internet. Take it easy, everyone.